All right. So we are talking today about models for growth and decay, and they have a lot to do with money. Does anybody invest their money? Raise your hand if you invest money. All right, in the back, people are investing. Nick's investing. Very good. Investing money is a great idea because if you just let your money sit in the bank, right, then you don't get any more money out of that. But if you invest it, your money is making money. It's a good idea. So we have a compound interest formula. We also use this formula to talk about other problems where things are growing exponentially or decaying exponentially. The same with this one, the continuously compounding formula. So this one is used when the bank might calculate your interest like every month. Every month they send out a statement and they say, okay, you know, this month we've added in your interest and you have a little bit more money. And then the next month they're going to calculate your interest based on what you had before and you have a little bit more money, okay? They might do that monthly or they might do it weekly. In theory, they could do it daily. This one is continuously compounded, and this one's really hard to actually think about because it's actually compounding your money like all the time. And not just like every second, more often than every second. It's really hard to wrap your mind around how that works. And the magic that makes it happen is this number E. And we've never talked about E before. E is called Euler's number. Some students might accidentally say Euler because that's what it looks like. But if you want to sound smart, then you're going to pronounce it Euler's number. Okay, now this number E is an irrational number like pi is irrational. It has digits that go on forever, and even though it looks like they repeat, they don't actually repeat, okay? So the digits go on forever, just like pi does, but we use an approximation to answer some problems. All right, most of the problems that we're going to do are going to use this compound interest formula. But whenever you see the word continuously, that is going to tell you that we're going to use this formula over here. We need to know what the variables stand for. So ending amount. It could be the ending amount of money, like after your interest is compounded, or it could be the ending amount of like people in a population problem. But A is the end amount. And P literally stands for the word principal, because in money, principal would be the money that you invest, but the start amount. And the reason it's called P is for the word principal, not the principal of the school, but the principal amount of money you invest. R is your interest rate, and you have to write your interest rate as a decimal. So they will tell you the percent, but then you make it a decimal. So it's the rate as a decimal. All right, N is the number of times they compound your interest per year. So, you know, if they compound per year, N is 12. If they compound it just once a year, N is 1. So the number of the interest is compounded. In a year. They can actually use a different time period too. So it could be the number of times the interest is compounded in a time period, but most of the time they're saying per year. And then T is the number, which is usually the number of years. And then finally this right here, which is part of your... The city of Reston, Virginia grows every year at a rate of about 0.47%. Now, 0.47% is not the same as 47%. 47% means that every year it would be adding half its population again. That would grow so fast. All right, 0.47% is less than 1%. It's growing each year, which doesn't actually seem like a lot, but it is. It's a pretty strong growth to grow 0.47%. We need to change that to a decimal. And I know it looks like a decimal already, but right now it's a percent. The word percent literally means per hundred. Percent means per hundred. So to change the decimal to to change the percent to a decimal, we divide by 100. I'm going to write those words down. To change percent to decimal, divide by 100. All right, so use your calculator now. And we're going to do R equals 0.47 divided by 100. And then tell me what you got. 0.47 divided by 100. Anybody get the same as Mustafa? 0.0047? Double check and see if you get it. Okay.
Yeah, I got it right.
All right, so that's the rate. We're going to use that in our formula, okay? Compounded annually. Annually means it's compounded one time per year. So that would be n equals 1. The population in 2019 was 58,404. That's your starting population. So that would be your P. And we're trying to find the population in 2025. So we're going to take the formula. Does it say that it's compounded continuously anywhere? Do you guys see the word continuous? No. So unless you see the word continuous, you are going to use the first formula. So we're going to write the first formula down. Okay. Let's focus. The P is this number. 58,404. We don't do plus or minus. It's not like the quadratic formula where there's two answers. There's just one answer for the population.
Plus, right, because it increases?
All right, Rodrigo says it's plus because it increases. Who agrees?
Yeah, it grows every year.
All right, very good. Good referencing the problem. It grows every year, so it is going to be a plus. If it was going down, that does happen sometimes in population, then it would be minus, okay? All right, so we're going to use the plus. Remember that the rate we found is the decimal 0.0047. And then we divide that by the number of times the interest is compounded in a year. So if it's compounded annually, then the n equals 1. Notice that the n is also used up here, 1 again, and then times the number of time periods. Now don't call this out. I want you to talk to your group for a moment. I want you to talk to your group about how many years have passed in this problem so we can figure out what number to put in for t. Talk to your group. Okay. How many years did you guys get? 6 years? I agree. 6 years between 2019 and 2025. So that would be times 6. Now. All right. All right, so I'm going to start by typing 58,404. Then I need parentheses. Did you guys find the parentheses above the 8? Okay. Then we said 1 plus, and I need to type in the 0.0047 divided by 1. And then what do I press to get the exponent? Yeah, it looks like an arrow. It's literally called caret for some reason. This one.
Oh, I got the answer.
Okay. And then see if you get the same answer as your neighbor. All right. So I forgot I was solving a population problem, and I started to tell my first period we should round this to the dollars and cents, and they're like, that doesn't make any sense because you can't have a fraction of a person, right? So we'll round it to a whole number. So round your answer to a whole number. See if you get the same thing as your neighbor.
1 plus 6,000.
All right, so I'm getting 60,070 people in Ruston. Anybody getting the same? 60,070 people? Good.
Yeah, you got the same thing. Oh, yeah.
60,070 people. All right, let's move on to the next problem. Now we're talking about money. You purchased a used car for $1,500 and it's projected to depreciate. What does depreciate mean? Decrease. Yeah, go down in value. All right, so it's going to depreciate 15%. So let's calculate your R based on 15%. It's going to be 15 divided by what? 100. Always 100. Percent means per 100. All right, get your decimal. Let's get 0.15. Okay. We have a start P of this, and it's compounded annually, which means that N is what? Formula. So let's see if we need to fix it, okay? All right, so this time we're depreciating. Okay, so take a look. If you calculate it with a plus, let's recalculate it with a minus. So our principal was 1,500. 1 minus 0.15 over 1 to the 1 times 1. Okay, and then I'm going to put that in the calculator. So if you haven't put that in the calculator yet, do that. Because N is 1 for annual. All right, so I'm going to type 1,500.
That would make sense.
Because if it's 665.5.
1 minus 0.15 divided by 1 raised to the 1 times 1.
Oh, 1. Always. I think that's always 1. Wait,
All right, so it's 1,275.
Oh, annually. It's okay, yeah. 1. It is N, but the problem is 1.
Okay, do you guys have questions on that one? If you answered that one, did you go ahead and answer the next one already? So if you don't want to have to retype everything, you can just press second enter to get back to what you typed. Because the only thing that changes here is the number of years is 5, right? So let's go back now and just do second enter.
665.5.
Second enter, and then change the T to 5. All right, and look, it's worth a lot less now, right? It's only worth $665.56. All right. A lot of the stuff is the same, but we have some new things. We have compounded quarterly. How many quarters are there in a year? 4. 4 is right, yes. So that means your N is going to be 4. And then they tell you compounded every minute, but then they kindly also tell you that there are 525,600 minutes in a year. So this is your N for the second problem. All right, so you're going to find out how much money you would have. All right, for the first bank. For the first bank, did you get $541.83? Yeah? Okay, good. If you haven't calculated the second bank yet, do that now, and then we're going to make...
it's gonna be so slow.
So notice, even though we compounded a lot of times, right, we're still able to use the formula. All right, so it's a different formula, right? For compounded continuously, we use the other formula.
Yeah, I use a different formula. I use this
Okay.
one.
So P equals E to the RT, right? Let me see if I copied it right. Yep.
Yeah, that's not bad.
All right. Now remember, E is a number. It's on your calculator. So we're going to use that, but let's identify our R and our T first. Yes. What? Oh, Pete, I'm sorry. Campbell's helping me out, and I'm ignoring him. A equals P times E to the RT. Thank you. Okay, this is our right formula. We still need to identify things, though, right? What is our P? What number? Good. This is our P. Now the E is a constant. It's on your calculator. The R is the rate. So let's calculate the rate by dividing 4 by 100.
So it's the same thing?
Not exactly. Evie says 0.04. Can anybody confirm 0.04? Okay.
Oh, so I just put A. I just put A here.
And then how much is T? Yes. Okay, so now let's substitute into the right formula. So E is a number. You're going to use your calculator, and I'll show you how. I forgot to record, so I'm just going to say that part one more time. We substituted in for P, R, and T, and then we used the calculator, the button for E. So when we typed it in, we needed to find E, and I used the button here, second, and then LN. Okay. Take a look. What did you get for after 3 years? Did you get the same answer? $1,691.25. Yeah? So your R is still 0.04, but this time your T is 3. So you just had to change that to 3. We got to fill out the bottom part, and then you'll be ready to do your delta math. You see something? You good? Give me a minute. All right, let's do this last part. If your interest is compounded annually, how many times is that in a year? 1 time, good. Semi-annually, N equals? So every half year, and then that means 2 times, right? So put it together, you got it. Quarterly means it happens how many times in a year? 4 times. Monthly, I think you got. How many weeks in a year? 52, that's right.
I thought it was 51.